This is a follow-up video from the one I recently posted about a review of two ITX NAS based motherboards featuring either an N100 or N5105 Intel CPU. There were a lot of good comments, and thank you for all the feedback and discussion there. It's much appreciated. But I thought I'd address a few of the questions here in a separate video. This video was hastily put together, but I thought it important to address the questions that were brought up. The items I will look at specifically are the Plex media server transcoding, the BIOS, HDMI and DisplayPort resolution and refresh, driver installation, and fan noise. Now there's two other items I wanted to address but didn't come up with anything conclusive. Those were idle power consumption and C states, as well as simultaneous bandwidth in both USB ports. I was not able to find any way readily to reduce power consumption either through the BIOS or through some OS commands. If there's something specific you'd like me to try, just let me know. I'll give it a shot. However, I thought I would let you know that I did use this EVGA 500 watt 80 plus gold power supply throughout my testing. And I recently just plugged in this Silverstone SX300 300 watt 80 plus gold power supply. And currently I'm idling in Windows right now with the N5105 motherboard, and it's idling at about 16 to 17 watts. So power supply has a little bit to do with it. Dropped a couple watts there compared to what I got out of the EVGA one. So, but I wasn't able to drop it down below 10 watts or so, like some people had said that I should be able to do. For the USB bandwidth, I don't really have the equipment to test that right now, so that I'm going to have to forego that for the time being. This is the one with the N100 CPU on it, and I'm going to be doing some transcoding with Plex. Because in my last video, many users indicated that the N100 should be able to transcode multiple 4K videos to 1080p without much issue using the quick sync video feature of the CPU. And I didn't experience that, but I did find out why, and I'll show you why in a second. Now I'm going to test both the N100 as well as N5105 version of the board, and going to run up to 4 videos simultaneously, but I'm going to be doing it from my desktop computer. So I'm going to transfer to a different room. Sorry about the audio quality. It'll be a different microphone and whatever. So, but it does have a bigger screen and it's a better CPU and all that. So that way it doesn't cause issues with playback either. Okay, so here I am at my desktop PC just to show you the quick specs. It's got a Ryzen 9 5900X CPU, 32 gigs RAM, GeForce RTX 3080 GPU. So it's just to show you that this will not be a hindrance to the playback of the videos. And thankfully, from this kind person over here at the Plex Reddit forum, mentioned that the HDR to SDR tone mapping for the Windows version of Plex does not make use of QuickSync video yet, but the Linux version does. So when I did my initial testing, I used Windows. So here I'm actually using Ubuntu Linux, and initial testing shows that it actually does seem to work rather well. So if I go over to the Transcoder tab here on the Plex Media Server, and see here that I'm using the hardware transcoding for the Alder Lake N. And then I have these 4 videos over here. Okay, I've got Guardians of the Galaxy, Dune, Batman, Die Hard, and I'll probably blur these out because copyright reasons, right? So, but we can get the information we need without actually seeing the video. In any case, we'll go ahead and take a look at each of the details of the videos here. So here's all 4 of the video files, and here's the information. You can see they're all 4K, 24p frame rate, 10-bit depth, and HEVC codec. And I'll go ahead and close these out. And then I'm going to go ahead and start up each of these videos. I'm going to bring up the Okay, now I'm going to go over to the dashboard here, and you can see all 4 running here. They're all direct stream video with some transcoding going on with the audio, but they all seem to be loading perfectly fine. Alright, now that these videos are playing, I've got this clock up here. I'm going to play it, so in case I have to fast forward the video, kind of get a feel for how long it's gone or if it's actually buffered out or whatever. But you can see all 4 here are all direct streams currently, and there are no issues with playback at all, and the CPU usage is actually pretty low. I'm going to go through and set each of these to a 1080p transcode, 8 megabit. All right, now they're all playing. We'll let them play here for a couple of minutes. Okay, now you can see that they're all playing here. They're all being converted through transcoding on the Plex media server. And I'm going to go ahead and bring up the dashboard here. And you can see they're all hardware transcoding the video. And also the CPU usage is actually at only about 50 to 60%. So it's actually doing quite well. And I'll let this run here for a couple minutes and see if we have any issues. Okay, so you can see we're several minutes into each of these videos. There were no stutters, no issues whatsoever. And it looks like we have a little bit more overhead for probably transcoding even a couple more if we wanted to. So apologies before. I didn't realize that that was a thing with the Windows Plex Media Server. And so this N100 can manage it just fine. So here's the N5105 version of the ITX NAS motherboard. And I have Ubuntu installed and Plex Media Server on that Ubuntu installation. And we're going to check for the 4K video transcoding here next. Okay, you can see we're back here on my desktop with the Ryzen 9 5900X CPU like before. And we're connected to the Plex Media Server on the N5105 NAS motherboard. And you look at the transcoder settings, they're the same as before. We've got the Jasper Lake UHD graphics selected, hardware accelerated video encoding. And then I'm going to go ahead and take a look at the details of each of these videos. They should be the same as before. And see here they're all 4K, 24p frame rate, HEVC 10-bit depth videos. And I'm going to go ahead and bring up each one individually like before. I'll also start the clock here just for reference in case I have to fast forward. And it seems like everything is loading up. Okay, so we go ahead and take a look at the dashboard here. You can see here they're all direct streams with the audio being transcoded. And you can see here it's been streaming for a little bit, and there's no issues here, and CPU is pretty low because it's at the same video format, frame rate, and resolution, so there should be an issue there. So I'm going to go ahead and start the transcoding on each of these and take a look at that. And switch to 1080p 8 megabit. And this is for Dune. And I don't know why this was showing down here, but here it's showing transcoding hardware. Let's start up Batman. 1080p 8 megabit. And here it's transcoding hardware. And now for Guardians of the Galaxy. Hardware transcoding. And now lastly, Die Hard. Hardware transcoding. So it seems to be able to handle 4 hardware transcodes, and looking at the CPU, it's running at about 30%. So I'll let this run for a bit and see if we have any issues with pausing or lagging. So you can see we're several minutes into the video, and we aren't buffering out or anything. Everything seems to be running fine, and we're only running about 30% CPU. So it looks like it can handle at least 4K transcodes at once, maybe more. I'm not sure if we push it too much, if the integrated graphics are going to start to choke and it starts to switch over to CPU. But either way, you can do at least 4. So the good news is that both CPUs appear to be able to transcode at least 4K videos to 1080p without much issue, as long as you use the Linux, not the Windows version of Plex Media Server, and ensure hardware QSV encoding is enabled. I apologize for the incorrect information in my previous video, but thanks so much for bringing it to my attention. I realized last time I didn't really show the BIOS of each of these motherboards, so I'll go through that really quickly. And there's a lot of features that you can see in here. The thing I found with some of these motherboards, they add all the options in here, but they're not always tied to features on the motherboard itself. So you can make changes, but it doesn't really affect anything. And I haven't spent a lot of time in here to really see what actually works and what everything does in here, but I'll give you a quick overview. And CPU configuration. So I'll just blow through each of these options pretty quickly, and you can take a look. One thing here is it does allow you to do a smart test through the BIOS, which is nice to see. So it has hot plug option here. GPIO settings. And that's it. And here's a quick look at the N100 BIOS. I haven't messed with the fan mode at all to see if that actually makes a difference. Here's an example of what I meant when I said about how if you make a change in the BIOS here, it doesn't necessarily affect the system. There's power on after power loss. By default, it is set to always on. I changed it to always off. What that means is when you power on the power supply itself, click it on, if you set this to always off, it will not power on your computer automatically. If you set it to always on, when you power on the power supply, it should turn the computer on automatically. But in this case, I leave it always off, and it still powers on the computer automatically when I power on the power supply. On the N5105 version of the BIOS, it doesn't do that. It operates properly when I change this setting. So just be wary that all these options in here may not have any effect when you make any changes to it or not. And I haven't spent much time with each of these options here to really tell you what do and what don't, but I have noticed it just with this simple change right here that it didn't affect it. I had a couple questions about the resolution output of this board, and I'm going to test it both in HDMI and DisplayPort and show you for both the N100 and N5105. So here we have the N100 hooked up with HDMI and connected to a 4K display in Windows. You can see here we actually get 4K 60 Hertz there, and there's the N100. N100 connected with DisplayPort with Windows. N100, and here again we get 4K 60 out of the DisplayPort. N100 with DisplayPort to Ubuntu, and you can see here there's the N100, and as far as display, we've got 4K 60 Hertz with DisplayPort. N100 HDMI Ubuntu. You can see there is the N100 and 4K 60 Hertz. N5105 HDMI with Windows. You can see here's the N5105, and it is 4K 50 out of HDMI. That's the maximum refresh rate. N5105 DisplayPort and Windows. N5105, you can see here it can get 4K 60 Hertz. N5105 DisplayPort out in Ubuntu. See, there's N5105 and display. You can see here we can get 4K 60 out of DisplayPort. N5105 HDMI out to Ubuntu. You can see there's an N5105 and then display. You can get 4K 50 Hertz out of the N5105 with HDMI. So here's a quick chart of those display resolutions, and the N100 can handle 4K 60 display resolution refresh on both HDMI and DisplayPort. N5105 can do 4K 60 with the DisplayPort, but for some reason it only goes up to 50 Hertz on the HDMI port. Here is the N5105, and I'm installing Windows again on it. And I want to try a couple of driver installers called Driver Booster and Snappy Driver Installer, as suggested by a couple of users in the comments in the last video. But Windows 11 doesn't like you to get on without signing on to a Microsoft account. I can't even get on, continue past this point, because I don't have any network drivers that are even on here yet. And I'll show you a little trick though, so you can actually bypass any type of network connection to actually install Windows. So the first thing you're going to want to do is hit Shift F10. It'll bring up a command prompt. Then you want to type OOB, click in the window, type OOBE/ for out of box experience, bypass NRO. Hit enter and it'll reboot. And after it reboots, you can go ahead and it should give you a prompt to skip network connection. Okay, so now we're back in here. Going to go through the prompts. And now we're back at the point where we were before, and here it says I don't have internet, so you have the option to continue. Continue with limited setup. Once I got Windows installed and the Ethernet drivers installed from a USB drive, instead of hunting down the other drivers, I tried both the driver installer options suggested by a couple of user comments from the last video. Thanks for the suggestions, by the way. These were Driver Booster by IOBit and Snappy Driver Installer. Now, first of all, Driver Booster had a lot of pop-ups on their site, and also their installer installed other programs on the machine that I didn't really ask for, and I don't remember seeing an option to deselect it either. The free version also limited the number of drivers you could install to 19. After that, you had to buy the program. It did seem to detect drivers, though, needed for the missing components, but I didn't continue with it because I wasn't comfortable with the added programs it installed without my knowledge and the spamware vibe it gave to me. So instead, I opted for Snappy Driver Installer at sdi-tool.org. It looks like it's completely free, although they do request Patreon donations, which seems fair. It instantly detected devices with missing drivers and ones that could probably be updated for both the N5105 and the N100. But like the N100 before, I had to go through 2 installation processes to get the audio drivers updated, but after that, everything was detected and installed properly. Now for the N5105, I think the Gigabyte chipset download I showed before is safe and legit option, but for the N100, Snappy Driver Installer seems like a safer route, rather than hunting down some drivers from a link in a forum to a Google Drive. So this does offer one additional option to install drivers. One quick update, I did have a question about fan noise, so I thought I'd show you real quick just what the with this decibel meter here, what the fan noise is. I really had not heard it over the power supply fan noise or anything else. So, and also repasting it dropped temperatures of the N100 by 20C and the N5105 by over 10C. And there's also a fan curve profile I guess you can set in the BIOS. I didn't mess with that at all, so that may also improve matters if it is too loud for you. Alright, so I have the N100 here, and I have unplugged the CPU fan, so I'm going to go ahead and start up the power supply so you can get a steady state idea for what the sound is like at idle without the fan, and then I'm going to plug in the CPU fan and then get an idea for what that fan noise is then. Okay, so we're powered up. Windows is pretty much at idle. I'm going to go ahead and plug in the CPU fan. Now for the N5105, unplug the CPU fan. Plug in the CPU fan. That's it for now. I hope you found it interesting and helpful. Until next time, talk to you later.